This is section 4.4, additional equations and inequalities. So we can actually use our calculator to solve some of these. So let's flip over there. All right. So for the first two, we can put those actually in numerical solve. So menu, algebra, numerical solve. Start with our square root. Arrow to the right, minus 2 equals x, comma x. And that's going to give me a positive 4. Let's do the one on the right. So menu, algebra, numerical solve. And that's going to give us a positive 5. So x is equal to 4. X is equal to 5. So again, since you do have to purchase this calculator, we're going to use it as much as we can. Now these are a little bit different. We do have to do a little bit of a manipulation to these, but it's not really bad. So both of these are to the third power. To the third root. To get rid of the third root, we can set them to the third power. Again, what you do to one side, you do to the other. So that power cancels out the root. All right, now from here, we see our highest power is a square. That means we can use C poly roots. But to use that, it has to be equal to 0. So let's move everything to one side. So let's move the 2x. And then move the 12 because we want the whole thing equal to 0. The order of the terms doesn't matter. Negative 23 minus 12 is minus 35. So let's put this in. So menu, algebra, polynomial tools, and I just used the poly roots. Let me go back to the notes real quick. Minus 2x. Remember with C poly roots, it has to be equal to 0. We don't put an equal sign, but we still do the comma x at the end. So negative 5, positive 7. So those are our two solutions, negative 5 and positive 7. If you were to plug them back into the original equations, it's going to make it true. Both of them will make it true, make it equal. All right, so same thing here. We have cube root, so if we put it to the third power, the cube cancels out the cube root, and we're left with what was underneath those radical symbols. Again, our highest power is a square. That means we're going to use C poly roots. In order to do that, it needs to be equal to 0. And it doesn't matter what side you move it to. And 4. Negative 14 minus 4 is negative 18. So we are going to throw this into C poly root. I'm going to flip back over and see what I wrote down. Minus 7x minus 18. Again, no equal sign, but you do have to have a comma x at the end. So the two answers we get are -2 and +9. And those are two solutions. All right, so let's look at these. All right. There's a couple ways we could do these. All right, so let's look at this. All right, so let's look at these. Now the power here is 2/3. I'm going to rewrite this in a different form. So this is the power. So that would be like the exponent, the power. That's where this 2 is coming from. And when you have an exponent that has a number on the bottom, that is the root. So that's where this 3 is coming from. Okay. All right, so I'm just going to rewrite it. I need to get rid of the cube root, so I'm going to cube both sides. So the cube root and the cube cancel out. So I'm left with x plus 1 squared. And 4 cubed is going to be 64. Now I need to get rid of the square. There's a couple ways you can actually solve from here. I'm just going to take the square root of both sides. So the square root and square cancel out. So you're left with x plus 1. And the square root of 64 is plus or minus 8 because 8 times 8 gives you 64 and -8 times -8 also give you 64. From here, I need to get x by itself. So I'm going to subtract the 1. So x is equal to -1 plus or minus 8. So -1 minus 8 gives me -9. And -1 plus 8 gives me a +7. So the two solutions are -9 and +7. All right, so we're going to set this one up the same. The top is our exponent. The bottom is our root. Now, to get rid of the third root, we need to raise everything to the third power. Those two cancel out. I'm left with x plus 8 squared. And 9 times 9 times 9 is 729. All right, again, from this point, we take the square root of both sides. Square root cancels out a square, so we're left with x plus 8. Let's see what the square root of 729 is. I don't know that one right offhand. That's going to be 27. But again, if it's the square root, it's going to be plus or minus 27 because 27 times 27 gives me 729. And -27 times -27 also gives me 729. From here, I need to solve for x. Get it by itself, so we move the 8. So we have -8 plus or minus 27. So -8 minus 27 gives me -35. and then -8 plus 27 gives me 19. So these two solutions are -35 and +19. All right, we're going to look at solving the inequalities. All right, so I'm just going to show you the easiest way to do this. We're going to set it up as an equation. And we need to move everything to one side. We're going to use C poly roots. I'm going to double check and make sure I put that in right. That would be -6, not +6. All right, so we have solutions at -1 and 2. Now this is an inequality, so it's a little bit different. Actually, let me move this down a little bit. All right, -1 and +2. So we need to find test points. So number less than -1, we could use -2. Between -1 and 2, 0 is an easy one. And greater than 2, we can use a 3. So we're testing the intervals here. This. So we're going to plug those values, those three values I have, into the original inequality. Make a little room here. All right, it should be clear now. All right. All right, so it's 4, 3. And it's 18. Is that greater than or equal to 6? Yes, that is true. There we go. So this piece is good. Anything less than -1. Let's plug in 0. All right, this one's not true. 0 is not greater than or equal to 6. So nothing between -1 and 2 is going to work. And I'll show you what that means in a minute. So let's test the 3. So 27. All right, so that also gives us 18, which is true. So the only places, the only numbers we can use are less than 1 or greater than 2. You kind of remember this from graphing inequalities. Okay, there's a line underneath the inequality symbol. So there's going to be brackets. Here we're going towards positive infinity. And here we're going towards negative infinity. And I'm going to erase some spots. I don't remember if they want interval notation or if they want inequalities. So I'm going to write both. All right, so if they want inequalities, x is less than or equal to -1, or x is greater than or equal to 2. So for interval notation, we're going to go from negative infinity to -1, which has a bracket because of the inequality symbol, union symbol, which is in the same area you find your infinity, bracket 2 to positive infinity. Again, I don't remember if they asked for inequality or interval notation, but that's both the correct ways to write those. All right, so this one's going to be the same. I'm going to start with setting it up as an equation and solve it or make it equal to 0. So we can use C polyroots to solve this. Squared. And no equal sign, put comma x. We get -3 and +9. That breaks up our interval. So from there, I need to find test points for each of the sections. So between a -3 and a +9, 0 is good. And I would use 10 here and -4. So we're going to test each of the little pieces. We're going to plug these back into the original. Okay. 80 is greater than or equal to 54, and that's true. Then we're going to plug in 0. So 0 is not greater than or equal to 54. So we can't use any numbers between -3 and 9. And then let's try 10. All right, so that piece is good as well. I'm going to go ahead and erase this, so pause it if you need to. All right, so we do need to plug each one of these test points in. No, we did that already. Never mind. Sorry. All right, so if they ask for an inequality, so we're good. Anything less than -3 or greater than 9, because the inequality symbol has a line underneath it, we have brackets on the numbers. So x is less than or equal to -3, or x is greater than or equal to 9. And for interval notation, we're going from -infinity to -3, and the inequality symbol says we have a bracket, union 9 to positive infinity. All right, we have one more question, I believe. Let's see if this is our last one. Yep, this is our last one. All right. 2 projectiles are fired into the air over a lake with the height of the first projectile given by this equation. And then the height of the second projectile is given by this equation, where y is in feet and t is in seconds. Before either projectile hits the leg, determine the time interval in which the second projectile is above the first. Okay, so when the second projectile, when is y2 above or greater than y1? I'm just going to go ahead and put an equal sign. All right, so I want to put everything on one side. If I add the 16t squared to both sides, those end up just canceling out altogether, which is fine. So let's move the 200t. Okay, so 0 equals 150. And 150 minus 200, so negative 50t. You can actually use numerical solve, but I'm going to go ahead and use C poly roots on this one. Sorry about that. $150. And you can use T or you can use X. If you use T, put comma T. So the solution is 3. So T is 3. Okay. So I want to look at these on a graph. Let's do the first one. Gotta change that to an X. I'm going to actually pause this for 1 second and adjust this window. There's the magic. I needed to adjust this window so you can see it. All right, so F2 is the second one, and they're asking when the second one is going to be taller than the first. So at 3 seconds, which is right here, it's going to be above the blue one, the first one, and it continues to be above it all the way until it hits the ground. Okay, so the first thing we did was we found that point of intersection. So at 3 seconds, the second graph, the second curve is going to be higher than the first one, and it's going to stay higher until until the second one hits the ground. So we need to find where the second one hits the ground. Okay, so that means we need to find where y2 is equal to 0. Okay, and I'm just going to use I'm going to use C polyroots for this. Square, get that real quick. Plus 200t. So at 0 and 25 over 2. So let's look at the graph again. So 0, okay, it's right here. It's still, but at that point, it's below the blue. But at 25 over 2, time-wise, that's where it lands on the ground on the right. So you want to use that one. Okay. That's still below the first one. So the other point is going to be at 25/2. So we have 3. That's where they intersect, where it starts to surpass the first one. And 25 divided by 2, I believe, is 12.5. Never trust myself. And at 12.5 seconds. Because after it hits the ground, it stops. We can't do any time past that. So those are the 2 solutions to that problem. And that is it for chapter 4.